everyone, and welcome to another math lesson with me, Mr. Duclos. Today, we are on day 1 of understanding fractions with addition and subtraction. Let's jump right in and see what we can do. Our objective today is to reason using benchmarks to compare two fractions. Now, a benchmark is a number or a fraction that you should always kind of know. It's something that we can refer to because it's something that we easily understand. So on our number line, I gave us a few benchmarks. We have 1, 1/2, and 0. And those should always be benchmarks that we're pretty comfortable with. We all should know what 0 looks like. We should all kind of know what 1/2 looks like. And we should all kind of know what 1 looks like as 1 whole. So using those benchmarks and nothing else, I can put our numbers, or fractions here, on this number line in about the right spot. They're not going to be perfect, but they're going to be in about the right spot using benchmarks. So the first one we're going to do is 1/3. And first thing I notice is that 1/3 is going to be more than 0. Because 1/3, if I have 1/3 of something, that's more than having 0 of it. So I know we're at least going to be past 0. But 1/3 is also going to be less than 1/2. And that makes sense. Because if I had a cookie, and I broke it into 2 pieces, and gave you 1 piece, you'd get more cookie than if I broke it into 3 pieces and only gave you 1 piece. So I know that 1/3 is greater than 0, but it's less than 1/2. So that means that on my number line, I can put in 1/3. And now again, that's not exact. That's not exactly where 1/3 is, but it's somewhere in that area. It's more than 0, it's less than 1/2. The next one we have is 2/3. And again, I notice that 2/3 is more than 0, so we're going to be going this way. And 2/3 is actually more than 1/2. And 2/3 is always going to be more than 1/2. And if you think about it again, it kind of makes sense. If you take that same cookie, you break it into 3 pieces, but you get 2 of those pieces, that's a lot of cookie. It's more than half the cookie. So 2/3 is greater than 1/2, but it's less than 1. So that means that somewhere in here, we're going to have 2/3. And again, that's not perfect on the number line, but it's pretty close, because I know that 2/3 is greater than 1/2 and less than 1. The next one we're going to do is a little trickier. It's 9/10. And now 9/10, the first thing I'm going to notice is that we are so close to 10. If you have 10 pieces of a cookie and you get 9 of them, you almost have the whole cookie. That's 9 out of 10 pieces of cookie. So that's going to let me know that 9 out of 10 is so close to 10 out of 10. It's going to be somewhere around here. It's definitely bigger than 2/3. It's still not as big as the whole cookie, but it's almost the whole cookie. So it's 9/10 of the cookie. So it's right next to our 1 whole. It's less than, but it's right there. It's close to it. And the last one we're going to do is 1/2, or 1/10. So in this situation, we have the opposite. Now we have almost no cookie. Out of 10 pieces of cookie, you have 1 little measly piece of cookie. So it's still bigger than 0, but it's going to be less than 1/2, less than 1/3. It's going to be right around here. That's not exact, but it's super close to the 0, because you know that 1/10 is going to be close to 0. And that's how you use benchmarks to find where fractions would go on a number line. We don't get exact, but it's a good way to get a feeling for fractions and where they are compared to other fractions. Because now I can look at this and I can go, well, what's bigger, 2/3 or 1/10? Well, 2/3 is more than 1/2, and 1/10 is less than 1/2. So without having to do any other math, I can kind of just know that 2/3 is going to be greater than 1/2. So that's what we use benchmarks for. Now we're going to try and step our game up a bit, and we're going to use some harder fractions that we may not be comfortable with, but still plot them on our line using nothing but benchmarks. Let's just jump right in. So the first one I'm looking at is 5/12. 5/12 is a bit of a tricky fraction. It can't be simplified into anything else. It's just 5/12. But if I really think about it, what would half be when it comes to twelfths? Well, 6/12 is equal to 1/2. So if 6/12 is equal to 1/2, 5/12 is just a little bit less. So even though I don't know exactly what 5/12 is, I know it's a little bit less than 1/2. So on my number line, I can put 5/12. I'm going to make it pretty close to my 1/2 mark because we know that's where it should be. Next, we have 7/8. Again, none of these can be simplified. 7/8 just is 7/8. We can't make it smaller. But if we look at it, 7 is only 1 away from 8. So we're so close to having a full 8/8. So if we're only 1 away, 7/8, that's going to mean that it's going to be close to our 1. We don't know exactly on the number line, but we know that 7/8 is close to 1. And then lastly, 9/17. Well, that might seem tricky because it's such a big number. 9/17, geez. But if you had 9 twice, let's do that real quick. If you had 9 plus 9 equals 18. So that means that 9 is more than half of 17, because 9 doubled is 18. So 9 is more than half than 17. So all I have to do is know that I'm past 1/2. I have 9/17. And again, it's not perfect. I don't know if this is exactly where 9/17 is, but I know that it's more than half, and it's definitely less than 7/8. And so now I know very easily that if I was going to put these in order, it would be 5/12, then 9/17, and then 7/8. And I did all of that just using benchmarks. We didn't have to do any division or any multiplication or any addition, just using our benchmarks. Just by understanding where 0, where 1/2, and where 1 are, we were able to put in the rest. So now we're going to move on to our problem set. As always, I'm going to do the first one with you, and then you're going to have to do the rest on your own. And the first thing you always do is you put your name in. You put both your first and your last name. This way your teachers know exactly who did the work. All right, let's jump in. The instructions say, tell where the fractions below would fall on this number line. And then you have a number line that's exactly the same as we'd been using before. 0, 1/2, and 1. And so what you're going to do is find out about where would 11 out of 12 fall on that number line, about where would 1/4 fall on that number line. It might be helpful for you at home to actually draw a number line and to plot them out. If you don't think you need to do that, that's okay. So I'm going to do the first one with you. We have 11 over 12. The first thing that I notice at 11 over 12 is that it's definitely more than half, because half of 12 is 6. So 1/2 would be equal to 6 over 12. And so since I know it's more than half, I'm only going to be looking at this section, more than 1/2. But how much more than 1/2 is it? Well, 11 is only 1 away from 12, and 12 is a decently big number. So we're almost there. We broke up that cookie into 12 different pieces, and you got 11 of them. And so that would mean that we're pretty close to 1. We're not all the way there. We don't have all 12 pieces of the cookie, but we have 11 pieces of the cookie. So it's going to go next to the 1, but not all the way there. You're now going to do 2, 3, and 4 all on your own. The instructions are exactly the same. For 5 and 6, you can use the same number line, or you can draw your own to compare a fraction. So we have 7/12 and 1/2. If you drew your line with 1/2 in the middle, 0 and 1, find where 7/12 is. Is it going to be more than 1/2 or less than 1/2? And then for number 6, you're doing the same thing. You have 7/12, which you marked up here, and you have 5/6. And you need to figure out, using your benchmarks, which one is greater. Good luck, and make sure to hit up your teacher if you have any questions. That ends today's lesson. I hope you learned a lot. Now you gotta go finish your independent work, and as always, have a great day.